So this one is the weekly homework of chemistry, the experimental techniques exercise 1. In this session, I will discuss the MCQs as well as the structured questions related to the topic. So in the first part, they mention a sample of a dye is investigated by chromatography. The line is drawn across a piece of chromatogram or paper and the spot of a dye are placed on it. So spot of a die is placed on it and the line is there. Which row is correct? What is used to draw the line? So whenever we want to draw the origin, we always prefer to use pencil. So either C will be answer or D. And then what should be the position of the spot? So the position of the spot should be above the solvent level. Like this is how we should place that the spot which we place should be above the solvent so that the spot or the ink does not dissolve it directly in solvent. So it will rise as the paper or a chromatogram absorb the moisture or soak up the solvent, it will rise. So the correct answer for this one is C. For question 2, the paper chromatogram below was obtained for 4 different dyes. Which dye has a RF value of 0.7? So how you can work out the RF value of the to be 0.7. So the RF value is a distance moved by the spot to a distance moved by the solvent front. So what you will do, you will measure this distance. So using a ruler, you will measure this distance. So as an example, say this was coming out as, according to your paper side, it may vary. Like I'm taking as 10 centimeter. So when we measure the distance of the spot from the origin, example, if it is coming out 9 centimeter, this is coming out 0.5 centimeter, this is 2 centimeter, and this one is 7 centimeter. So for spot B, it is coming out example 5 centimeter, this is 3 centimeter or 2 centimeter, and this one is 70 centimeter. So when we find the RF value is the distance moved by the spot from origin divided by distance moved by the solvent. So this will come out as 0.9. When we find for B, so it will be 5 divided by 10, that's equal to 0.5. For C, it will be 2 divided by 10, 0.2. And for D, it will be 7 divided by 10, so it will be 0.7. But you will measure, with a ruler you will measure. From the origin, we measure from the origin till the center of the spot, we measure that length. So this will come out as 0.7, so the correct answer will be D. So whenever we are measuring a distance of the spot, so from where we measure, from the origin till the center of the spot, we measure this distance. From the origin till the center of the spot. Not to the bottom, not to the top, till the center. In question 3, in the chromatogram experiment, which label represent the solvent front? So B is representing the spot, C is representing the solvent, D is representing the origin or the baseline, and A is representing the solvent front. So A is the right answer for this question. In question 4, they're mentioning that X is a mixture of colorless compounds. So is a mixture of colorless compound. The diagram shows a chromatogram of X and of three pure compound P, Q, and R. So there is compound P, Q, and compound R, and X is an unknown substance. Which statement is not correct, or which statement is not true? A locating agent is used to develop the chromatogram of X. That's true. Why it is true? Because they mention it is a colorless substance. So when we have a colorless substance, so for colorless substance we use locating agent. That's true. P and R could be present in X. So how we can identify? You can see the spot of P is there in X and spot of R is also there in X. So it means P and R could be present in X. That is true or correct. P and R have different solubility. That's also true. Why P and R have different solubility? You can clearly see that the height to which the P rises is different from R. P rises to a shorter distance where R rises to a greater distance. It means R is more soluble. That's why it rises more with the solvent. So statement C is also true. Q has a greater RF value than R. That's wrong. Why? Because RF value, when you work out the RF value, if the spot moves to a greater distance, then it will have a higher RF value. So when spot rises to a greater distance, it will have a higher RF value. So the RF value for R will be greater than, when we calculate the RF value of R, that should be more than the RF value of Q. But in the statement is it written that Q has a greater RF value, and they're asking which is not correct. So which statement is not correct? D is not the correct statement. Is it clear? Because we have to work out the wrong statement or not correct statement. Is it clear to everyone? In MCQs 5, chromatography experiments are carried out. Four substances are there: P, Q, R, and S. The same solvent is used for each. The resulting chromatograms are shown below. Which statement is not correct? Not correct means which is a wrong statement or not a true statement. In the first one, P and Q are pure substance. P and Q are pure substance. That's true because we only see only one spot. That's true or that's right. P and R are different substance. P and R are different substance. You can see because P rises to a different height. The spot of P rises to a different height as compared to spot of R. If we are using a same solvent, so it means they are different substance. That's also a correct statement. R and S are pure substance. R is pure, but S is not pure because there are two spots. So this is not the right statement. And S is a mixture of substance. That's true because there are two or more. Whenever two or more spots in a chromatogram, it means that substance is not a pure substance. It is a mixture. So C is the right answer for question 5. In question 6, the diagram shows the apparatus used to separate different components of a mixture by chromatography. Which statement about experiment is correct? Or which statement about the experiment is true? A locating agent is used to find the position of the solvent front. We don't use locating agent for solvent front. We use locating agent to make the spots visible. The components to be separated must be soluble in solvent. That's true, because if they are soluble, then only they will rise. If they are insoluble, they will not rise with the solvent. So B is the right statement. The baseline on which the spot of the mixture is placed, drawn with ink, that's wrong. We should always draw with pencil. And RF value is a distance traveled by solvent. That's wrong. It is distance traveled by the component divided by distance traveled. It's written opposite or reciprocal. So statement B is the right answer. In question 7, a chromatogram obtained from the chromatography of four substances. Which substance has a RF value of 0.6? The solubility. What's your question, Abdullah Sarfraz? Yes, Abdullah Sarfraz. You can use a mic to ask your question.
Yes, sir. My question is that in Google it's written that solubility does not affect the distance.
Solubility of a component in a solvent depends. It affects the distance. If it is more soluble, it depends on both factors. It depends on, when you study in detail, you will find it depends on both things, the forces between the mobile and the stationary phase. But right now in O levels, you will consider the one which is more soluble will rise to a greater height. But there are more details about it. But in O levels, you are only taking one part of that. So you consider, whenever you try to answer like which spot rises to a greater height, you will always consider that the one which is more soluble will rise to a greater height. Clear? Question 7. A chromatogram obtained from chromatography of four substances. Which substance has a RF value of 0.6? So which substance has a RF value of 0.6? The formula to calculate RF value is the distance moved by the spot divided by distance moved by the solvent. So when we divide distance moved by the spot, that is 6.3. Distance moved by the solvent front 10.5. So this will come out as 0.6. So for question 7, D will be the right answer. But because in exam you will check for all of them, I know the answer, that's why directly I just explained that D is the answer. But in exam, when you're solving, you should check each value, like 5.5 divided by 10.5, 5.2 divided by 10.5, 5.8 divided by 10.5. In question 10, the diagram shows a chromatogram of four substances. Which substance has a RF value of 0.32? So how you work out the RF value? RF value is the distance moved by the spot divided by distance moved by the solvent. So 6 divided by 19. For A, it will be 6 divided by 19. For B, it will be 14 divided by 19. For C, it will be 4 divided by 19. And for D, it will be 12 divided by 19. So when we work out, for A, it will come out as 0.32. In question 9, a student used chromatography to analyze a green food coloring. The chromatogram obtained is shown, which the table lists some yellow food dyes and their RF values. Which yellow food dye does the green food coloring contain? So there is a blue spot and there is a yellow spot. So how we can work out this? We have to use a ruler to measure the distance moved by the, so using a ruler you will measure distance moved by the spot and the distance moved by the solvent. I'm just taking these values. Example, if this was 3.2 centimeter and this was 10 centimeters, so when we divide 3.2 divided by 10, it will come out as 0.32. And according to your scale, your paper size, you will measure these distances. They're asking for yellow spot. So to calculate for yellow spot, distance moved by the spot divided by distance moved by the solvent. And when you work out the values, it will come out as B. So question 9, B is the right answer. Is it clear? So using a ruler or a scale, you have to measure these distances. It cannot be D. Why it cannot be D? Because the yellow spot, if it is zero point 0.8, I told you, like if it is, like this was a chromatogram, if you are getting a spot in this region, it will be less than 0.5. It is, you are getting above the half region, it is more than 0.5. So you can clearly see this yellow spot is not in the halfway mark, it is below the halfway mark. So its value cannot be more than 0.5. It will be obviously less than 0.5. Is it clear? Discussion. So using a ruler or a scale, you have to measure a distance moved by the yellow spot divided by distance moved by the solvent. We don't, because they did not ask which blue color, they simply asked which yellow food dye or yellow color is there. So B is the right answer. In question 10, the results obtained from a chromatogram are shown. The solvent distance traveled by the solvent is given, and the distance traveled by substance X and substance Y is also given. So what is the RF value of X and what is the RF value of Y? So RF value of X, that is distance moved by the spot divided by distance moved by the solvent. So 3 divided by 5, that will come out as 0.6. That is for X, and for Y distance moved is 2.5 and divided by distance moved by the solvent, so 2.5 divided by 5 is 0.5. So B is the right answer for this. For question 11, a student carried out a paper chromatography on a mixture of amino acids. What are amino acids? Amino acids are colorless liquids. So the student sprayed and the dried chromatogram with locating agent. What is the function of locating agent? So the locating agent actually make the spots visible. So when the locating agent make the spots visible, that is to form the colored spot. Abdullah Sarfraz, if you read the question, RF value for X. So what is the RF value of X? The distance moved by X, that is 3, and the distance moved by spot, the solvent, that is 5. So 5 divided by 3, that is 0.6. And for substance Y, what is the RF value of substance Y? So substance Y moves 2.5 distance, as you can see it's written here, divided by distance moved by the solvent, which is 5. So 2.5 divided by 5, that's equal to 0.5. That is why B is the right answer, that X moves 0.6 and Y moves 0.5. In question 12, the painkiller paracetamol is synthesized from 4-aminophenol. This 4-aminophenol is the name of a compound which is used to manufacture paracetamol. It's a painkiller. Chromatography was carried out on an impure sample of paracetamol. So we have impure sample of paracetamol and we carried out chromatography. The sample of paracetamol is contaminated with 4-aminophenol. What is the meaning of contaminated? It means like paracetamol contain 4-aminophenol as well. Some of the paracetamol. RF value of 4-aminophenol. So how we can work out the RF value? They mention impure sample of paracetamol is S. So this is impure sample. It means it contain paracetamol and it contain this S contain paracetamol and it also contain 4-aminophenol. And P is pure paracetamol. So P is pure paracetamol. In the question, they're asking the RF value for 4-aminophenol. So the paracetamol, this spot shows it is paracetamol, this part. So if this is paracetamol, then this will be 4-aminophenol. So we have to just find the RF value of 4-aminophenol. So a distance moved by the spot is 2.6 and the distance moved by the solvent is 0.35. So when we find the RF value for 4-aminophenol, that is 0.26 divided by 0.35. So it will come out as 0.74. So C will be the right answer. 0.26 divided by 0.35. Because we don't need RF value of paracetamol, we need RF value of 4-aminophenol. And they mention that 4-aminophenol, this sample contained paracetamol as well as 4-amino. So this is a spot of 4-aminophenol. Is it clear? Any doubt in MCQs till now? Is it clear to everyone? The first 12 MCQs. Now the structure questions. The structure questions, leaves from tea contain a mixture of colored pigment. So there are colored substances are present in leaves which are not soluble in water. So it does not dissolve in water. The colors which are present, like example, there's a leaf. It is having colors, but it's not water soluble. A student was given these two instructions to investigate the pigment in the leaf. So student is given the two instruction to find the color in the leaf or the pigment in the leaf. Number one, crush some leaves to extract the colored pigment. So first he should crush the leaf to extract or to take out the color pigment and then use the liquid extract to find the number of colored pigment. So how he can find how many colored pigments are there? So what would the student need in order to effectively carry out instruction 1? How he will carry out instruction 1 means how student can crush the leaves and extract the pigment. So if you want to crush the leaf, so which lab apparatus we can use to crush the substances? So we use mortar and pestle. Yeah, that's right. So student should use mortar and pestle to crush the leaves. That is one thing. But we want to extract the color also. We want to remove the color from these leaves as well. So if we want to extract the color, what we can do, we can boil the leaves in alcohol. Why alcohol? Because they mention it is not water soluble. So first what we did, we crushed the leaves. by using a mortar and pestle, and then we will filter. That filter will be the third part. So this is mortar and pestle. So when we crush the leaves, so we have these crushed leaves. After these crushed leaves, what we can do, we can use alcohol as a solvent, and then we add these leaves and heat, boil. So when we boil, now the colored is removed from the leaves, and then what we can do, we can filter to remove the solid particles or remaining of leaf. Liquid extract. So what we are left with now, that is a liquid extract, the color. Why we should boil the leaves? Because for when you boil something at high temperature, the substance tend to decompose, substance tend to break down, and it increases the rate at which the substance dissolve. That's why we are boil the crushed leaf in alcohol or heat. Even you can, instead of writing boil, you can mention the term heat as well. So when you boil or heat, increase the temperature, so it will be a fast process. Yes, Abdullah?
Sir, but if we will heat it,
Hmm?
the color can also boil or evaporate.
No, it's when you are heating or warming a solution, evaporation can happen, but a small amount of liquid will evaporate. Most of the liquid will be there because evaporation is a slow process. It's not like when you sell, even for example, you take a container and fill with a glass of water and supply heat energy. It's not like all of the water evaporate instantly. It take time. So you can just warm a solution, and purpose of warming is that maximum amount or greater rate of dissolving or greater rate at which we can extract the pigment or color. Is it clear till now, this point? How we carry out instruction 1? Is it clear to everyone? Yes, Abdullah?
Sir, if we will heat it, will the leaves will like may be smaller or something? What is the use of it?
The use of heating it to extract the color. Like the leaves have color. The pigment, the term, as you can see, they mention leaves from the tea contain a mixture of colored pigment. So they mention leaves contain different colors. We want to remove the color out. Like example, making a tea. When you add, like example, you want, for example, what happened if you take a glass of water and you add a tea, a small quantity of tea. What will happen? Will it change the color of water? Yes, Abdullah. You take
Sorry,
a
sir, I didn't hear you.
what I'm saying, you take a glass, fill it with water, and add, for example, a pinch of tea leaves. Actually, tea leaves are there, so you add pinch. Will it change the color? No, it won't change the color. What you have to do to extract the color out from the leaves, you boil the water or you heat the water so that that color and taste is removed from the leaves. So same thing happen here. To extract the color, we just heat it so that the color is removed from the leaves. Clear?
Yes, sir.
The second part, use a liquid extract, find the number of colored pigment. So using a liquid extract, how we can find the number of colored pigment? So what we can do, we can use a chromatography, draw origin with pencil, apply the extract on the origin, and what we can use by the help of dropper. And it is better you mention many operators in your explanation so that it shows that you understand the concept. Use suitable solvent which can dissolve, extract from leaves, and measure the RF values. So we can measure the RF values because in the second part they're asking use a liquid extract to find a number of colored pigments in the leaf. So how we can do, we can use chromatography. By using a chromatography, what we'll do, we'll draw the origin with pencil, place the extract like which we obtained in the first part, then use a suitable solvent, not water because they mentioned it is not water soluble, so you can not use water, any other. And then you can mention count the number of spots, you can mention that also, or you can mention measure the RF value to know how many colored pigments are there in this leaf. Is it clear, this experiment? Any doubt? Yes, Abdullah Sarfraz. Okay, next question. They mention E110 is a sunset yellow. I told you that these are numbers given for food colors. So E110 is a sunset yellow. Outline a method you could use to show the presence of E110 in a food coloring. So how we can check that there's a food coloring and that food coloring contain E110? First I will explain the idea and then I will type. So what we can do, we can take a chromatogram. We'll draw the origin with pencil, okay, and then we'll place a food coloring here. So food coloring, I'm writing FC, means food coloring, and then we place E110, a sunset yellow or a yellow color. Then we place E110. We have to show that E110 is present in the food, the presence of E110 in a food coloring. So food coloring may have different spots, but one of the spot will match with E110. So if one of the spot matches with E110, it means that this food color contain E110. So how we write this answer? So we will use chromatography. Then we will draw the origin with pencil. Place sample of food color and E110 on origin. Then use a suitable solvent. Here they did not mention it is not water insoluble in water, so you can mention use water as solvent. Then we will compare the position of the spots. or you can mention compare RF value to show food color contain E110. Is it clear this experiment? How we can show, and whenever you draw a diagram, it should be a labeled one. So you should mention like this is a chromatogram, a solvent, origin or a baseline, solvent front, and the spots. Is it clear this experiment in which we show that this food coloring contain, because we want to show that food coloring in the question outline a method you could use to show presence of E110 in a food coloring. So we want to show that a food coloring having E110. So what we did, we take a food coloring and we carry out its chromatography, as well as simultaneously we carried out a chromatography for E110 separately. So when we check the height, because E110 and food coloring both have the same spot, so if they both have the same spot, what it shows that this E110 is present in this food coloring. Is it clear now? So this was a weekly homework, experimental technique exercise 1.